Okay, so we've turned in 11.5 and we're going to start 11.6. 11.6 is all about standard deviation. And I've asked you to get a whiteboard and a calculator. Our objective today is to find the standard deviation and the variance of the set of values, and to apply that standard deviation and the variance. So we've already collected the homework, so we're going to go right into Bell. What does the word standard mean? Does anybody have an answer for that? Yes. What regularly happens. So if you go to, and good job, if you go to a restaurant and they say the standard of food here is grade A or 3-star, then you're going to expect good food and consistently. It means that's its standard. If you go to a 5-star restaurant, you would expect its standard of food to be well above the norm, right? Standard means how something usually is. So your standard grade might be your average grade, right? Or you just have different standards of behavior, right? So you can use standard in a lot of ways. Okay, so but we're going to apply it mathematically today. How about the word deviate? Anybody know what deviate means, Ashton? To let go against the grain. So maybe to move away from the standard, to deviate. Yes, so very good. So if we put those together, it would be what I just said. To say what is standard deviation, it might mean how far is something away from the standard? How far is it moving away from what is standard? And that's what we're going to talk about today. So let's look at some formal definitions. Standard in definition is just a level of quality. Level of quality. And then deviation, I've copied this. It's the act of departing from an established course or accepted standard. So moving away from what your standard is. Okay. So that's going to bring us now to back to math in our lesson. Standard deviation is a measure of how far the numbers in a data set deviate from the mean. And we talked about mean. We said we can show the mean, which is just your average. So we show it with X bar. So you'll hear me say all of those. Average, mean, X bar, they all mean we've added a number of items together and divided it by the quantity of items to get an average. So in the previous lesson, we studied range and interquartile ranges with the box and whisker plots, right? Each of these is a measure of variation. A measure of variation describes how the data in a data set are spread out. Okay, so variance and standard deviation, I've underlined here, are measures showing how much data values deviate from the mean. We're going to use the Greek letter sigma, which looks like an O with a little dash to the right of the top of it. It represents standard deviation, and sigma squared is the variance. So these are the two things we're going to focus on today. Okay, standard deviation, sigma, and sigma squared, which is variance. Okay. Any questions so far? All right, let's move right into our key concepts. Okay, to find the variance and the standard deviation, you have to do certain things in steps. So the first thing you're going to do is find the mean of all the n values in a data set. Excuse me. Then you're going to find the difference, x minus x bar, between each value x and the mean. Next, you're going to square each one of those differences, and then you're going to find the average of these squares. That is called your variance. So it's the average of all the movement away from the mean of all the data values in a set. This is what it looks like. So sigma squared, which we said was variance, is sigma squared, is equal to, and the sideways m is a summation symbol. It means the sum of, it means I'm going to add up all of these, the item or the data item minus the average squared, all divided by the number of items. And we'll work with this in detail in just a minute. After we get that, then take the square root of the variance. So once you get the variance, how could you get sigma? If I had sigma squared equals 100, well, if I want to know what is sigma, or our standard deviation, you're just going to take the square root of each side, right? So it's just the square root of the variance. Okay, so once you get the variance, the standard deviation is the square root of that. Okay, and that's everything. This is everything we're using today. And I copied the formulas again down there. Again, sigma and sigma squared. Sigma squared is our variance, and sigma is our standard deviation. Any questions so far? Now they're going to take us step by step to work the first few out, and let's do that. They're going to take us through all these steps using a table. So let's look at our first problem. Problem 1 says finding the variance and standard deviation. And I've highlighted what are the mean, the variance, and the standard deviation of these values. And they give us 6.9, 8.7, 7.6, 4.8, and 9.0. So the first thing we want to do is make a table. All right, so I've copied those formulas again over there. There's the sigma and sigma squared, variance and standard deviation. But we really don't need those right now because this table is going to take us through all that. So the first thing we're going to do in the first column is just list all of our data elements. And there they are, 6.9, 8.7, 7.6, 4.8, and 9.0 in this first column. In the second column, you're going to take the average of all these. And here they've calculated the average to be 7.4. So that stays the same no matter what element you're on in the data set. The whole data set has an average of 7.4. So copy that down the second column. Now the next step was to subtract that average from the element. So now it's x minus x bar. So 6.9 minus 7.4, that's negative 0.5. And you do that all the way down. 8.7 minus 7.4 is 1.3. 7.6 minus 7.4 is 0.2. 4.8 minus 7.4 is negative 2.6. 9.0 minus 7.4 is 1.6. Let me clear that up. All right. So now that gets us through the third column. The last column is to take this number and square it. So negative 0.5 squared is 0.25. 1.3 squared is 1.69. 0.2 squared is 0.04. Negative 2.6 squared is 6.76. 1.6 squared is 2.5. And now the last step that we listed in our previous concept page was to add all those together, the summation of those. Remember, in our formula, you sum the squares of the differences of the items from the average. So we need that summation to finish this top portion of our variance. And when you add all those up, you get 11.3. Now, that gives us that numerator right there, 11.3, right? Now we have to divide that by the number of elements, which was 1, 2, 3, 4, 5. So 11.3 divided by 5 gives us our variance. And when you get that, it's 2.26. So our variance, sigma squared, is equal to 2.26. That's how you get the variance. Now, how do we get the standard deviation? Take the square root of the variance. So square root of 2.26 is 1.5, or approximately, they've rounded a tiny bit, approximately equal to 1.5. They've rounded to 1 decimal point. But remember, when you round, you've got to change your equal sign to an equivalent sign, or congruency sign, the wavy one. So what did they ask us for again? The mean. So we got the mean was 7.4, variance 2.26, and standard deviation 1.5. And that's it. That's how you work these. Does anyone have any questions on this? Okay, let's look at our homework 11.6. And the first problem is actually worked all the way through. There's not even anything to fill in that I saw. Number 1 says, find the mean, the variance, and standard deviation for each data set. Mean, variance, standard deviation. So that means we need our x bar, our sigma squared, and our sigma. Okay? Now, what they do, they repeat the table. And here's our data values, 6, 13, 12, 9, and 10. And there they are. Put it in. And now the average of all those, add them all together and divide by 1, 2, 3, 4, 5. There it is. 50 divided by 5 is 10. So 10 goes straight down the second column. So there's your x bar. The next step is to subtract those two columns. 6 minus 10 is negative 4. 13 minus 10 is 3. 12 minus 10 is 2. 9 minus 10 is negative 1. And 10 minus 10 is 0. Okay, so now we've got that column. The last part is to square each one of those. And negative 4 squared is 16. 3 squared is 9. 2 squared is 4. Negative 1 squared is 1. And 0 squared is 0. So now we've got a good majority of our variance calculated. So now we have to take the sum of these and then divide it by the number of elements. 1, 2, 3, 4, 5. So our n equals 5, right? So when you add 16, 9, 4, and 1, you get 30 divided by 5, which is 6. So there's our variance. Our variance, well, we know our mean, x bar equals 10. The variance, sigma squared, equals 6. And now take the square root of 6, and you'll get your standard deviation. And the square root of 6 is, oh, there it is, 2.4, approximately 2.4. Any questions? We've worked 2 of those. It's whatever the number of elements were. If I had 6 elements in here, like if I had a 16, 6, 13, 12, 9, 10, and 16, then the number of elements would be 6. Then you'd be dividing by 6. Because you're taking an average, you're always going to divide by the number of elements. Okay? Does that make sense? Is that good? All right. All right. So, and it's just been 5 because the last 2 had 5 elements. Let's look at number 2 and work number 2 together. They give us in our workbook 8, 16, 12, 15, and 4. So I've already typed those in here in my first column. 8, 16, 12, 15, and 4. Now what's the standard, or excuse me, the average of those? Let's add these up real quick and divide by how many elements do we have? 1, 2, 3, 4, 5 again. So we're going to go 8, whoops, turn it on. Don't forget to clear your calculator. Let's go 8 plus 16 plus 12 plus 15 plus 4. 1, 2, 3, 4, 5. And enter. Looks like it's 55. Everybody agree? So the sum was 55. I'll just pencil it in right there. And then we want to divide that by 5 elements. And it's pretty easy to see that's going to be what? 11. So our average or our mean is equal to 11. Now, do your x minus x bar. So that's going to be a negative 3, 5, 1, 4, and negative 7. The next step is to square each one of these numbers. Square this column, so it's going to be 9, 25, 1, 16, and 49. Now, you're going to sum those and divide by the number of elements, and then you'll have your sigma squared. So 9 plus 25 plus 1 plus 16 plus 49 is equal to 100. And correct me if I'm wrong, divided by 5. So it's going to be 20. Yeah, that's what I got. All right, and now to get sigma, we're going to take the square root of 20. So square root of 20 is equal to, alternate answer, 4.47 blah blah blah. So I'm going to say about a 4.47, okay? Or let's go ahead and round to 1 decimal place, 4.5, okay? So there's our sigma, standard variation, variance, and mean. I'm sorry, standard deviation. I'm doing too many things at once here. Any questions over this? Okay, work the next 2 quickly. Work 3 and 4. And then I'm going to show you a shortcut. Do it the same way. What?
How do you make this a decimal?
Oh, okay. Got it? Are you holding it?
Yeah.
So it's this one. Push that one more time. There you go. Did it do it?
No.
Oh, press enter. Okay, and now. What is going on? Did you clear your calculator? Okay, I cleared everything. Okay, now you're going to go. Second function, square root of 20 to radical 5, alternate answer, there. To get the alternate answer, like if you did the square root of 20 and you got 2 radical 5, you have to press that little button like this, right above the enter key, to get the alternate answer. Okay, so it'll take it from 2 radical 5 to 4.47 when you press this key right here. All right. What? Yes, do 3 and 4. Okay, so you should be pretty close to finished. I've given you plenty of time here. Let's compare answers. And let's see, I do have a key. So for number 3, here are my answers. Did anybody get anything different? I'm opening up the answer key here. Make sure it's all good. So I made mistakes too. Okay, so yeah, the mean was 20. The variance was 8.3. Don't forget that, because well, if you take off the repeating sign, then we can give it a congruency. Okay, and then the standard deviation was equivalent to 2.9. So those are correct. And then for number 4, you have a mean of 34. That was correct. Variance was 52.3. Yes. And standard deviation was approximately equal to 7.2. Okay? Any questions over those? Now I'm going to show you the easy thing. Okay, get your calculators and make sure you clear everything out. So hold your on button and hit clear. And it should say memory cleared, nice and big. Now, clear those words off. And I want you to hit the button that says data. So from the green second button, go over 2 and down 1, and it will say data. Press the data button. And you're going to see 3 different columns, and at the bottom left it says L1 sub 1. Okay, so I want you to type in this first data element right here, 27, and press enter. And now press the next element, 34, enter. And now 45, enter. 30, enter. 26, enter, and 42, enter. What we've created is the first list. We could put 3 lists on a page, but we're not there yet. That's for much more complex problems. We're just dealing with one list. So we've got 34, 27, 34, 45, 30, 26, 42. Now, let's go to statistics on this. And if you notice, statistics is the green letters right above the data button. So press your green button and hit that data button again. And now we're in statistics. And we're going to tell it. We've got a 1 variable statistic because we're just using X, right? So press enter. And next it's going to come up and say, what data are we using? Well, we're using L1, list 1, so press enter. And frequency, I think that is 1, so press enter. And then it takes you down to calculate. We're ready to calculate, so just hit calculate. So take all the defaults. And it's going to come up and give you all of your 1 variable list information. And it tells us our number, for number 1, it says n equals 6. So we had 6 items. And the next thing, number 2, is x bar equal 34. Oh, x bar did equal 34. And the next thing, forget that one. Scroll down with your cursor, circle. There's x. Keep going. Let's see. There is your sigma x. There's sigma x, right? What was our sigma? Standard deviation, 7.2. There it is. And I don't know if we've got the other one on here. It's not there. But those, notice that there's lots of stuff there. There's your quartile 1, 27, medians 32, quartile 3 is 42. So you could quickly make a box and whisker plot off this too, right? With your first and third quartile and the median. Then you've got your minimum and maximum. How quick could you make a box and whisker plot off that without any calculations, just entering in the data? All right, so that's what the next two problems are about, is learning how to do this in the calculator. But I wanted to use one of our previous examples to teach that with. So let's try it. Are there any questions over that? Let's try it one more time. So hit clear, hold on and clear, and just clear everything out again. I don't know any other quick way. In the big calculators, the graphing calculators, I can clear the list out real quick, but I haven't figured it out on this one. I haven't had time. So I just clear everything. All right, so now in meteorology, this is problem 2. The table displays the number of U.S. hurricane strikes by decade from the years 1851 to 2000. What are the mean and the standard deviation? So they went X bar and sigma. So we can get that right from this. So here's our decades. We have 15 decades, so we know n is equal to 15. Here's what we want to enter in our list 1. So go to your list 1 again, hit your data button, and you should be right inside a blank list 1 if you cleared everything out. Now we're going to enter this data, 1915, so 19, enter, 15, enter, 20, enter, 22, 21, 18, 21, 13, 19, 24, 17, 14, 12, 15, and 14. I typed 132 on one of those. Now, it should say L1 16 equals blank, and that's correct because we just had 15 items. All right, so now we've got everything typed in. Now let's do our statistics. So hit the second button, the green button, and hit that data button again. And that's in our stats screen. So take all the defaults, so enter, 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 and you should be able to calculate. Enter again. And there they are. So there's your N items is 15. X bar is 17.6. And let's go down and find sigma X. There it is. There's your standard deviation, 3.5, about 3.5. And we're done. Excuse me. Okay. And this is what it looks like on the big graphing calculators. Excuse me. Any questions on this? I prefer the calculator way, right? It's pretty quick. So now just work the next couple of problems, work 5 and 6, and do those quickly. And then we have, I'll give you about 2 minutes to do these. What's the mean and standard deviation? So again, you're just going to enter those in. And enter your answers. Make sure you know how to do this because this is a lifesaver on a test, right? I put 6 up here so you can compare and make sure you're doing this correctly. But I'll check your number 5. About 30 more seconds, guys. We have one more problem to learn and 2 more to work. So, and then we'll turn on our paper. Okay. If you'll get your whiteboards and flip them over, well, you can use either side. I want you to make like a number line. All right. Okay, if we had, and let's just number this 10, 20, 30, 40, 50, 60, 70, 80. Okay? I'm going to say I've got an average, my x bar is equal to 40. So I'm going to draw a line here at 40, showing my average. There's my x bar at 40. Now I've got some data elements. I'm going to have some at, let's say 35, 50, 18, and 58. Let's mark those real quick. So 35 would be about right there. 50 would be here. 18 is about right there. And 58 is about right there. Okay? Now, what if I say my standard deviation, my sigma, is equal to 15? Okay, so let's find how far these scores, how many deviations these scores are sitting inside. So if we go 1 standard deviation out, so that means 15 away from the standard in both directions, we're going to go to 40 plus 15 is 55. So I'll use a different color. So there's my first standard deviation. And we got to go the other direction too. So it's going to be at 25. Okay, so there's my first standard deviation. Now, if I didn't, how do I put this? Okay, this score and this score falls within the first standard deviation. Okay, but I've got more scores that aren't included, so we need to go out 1 more standard deviation to include them, right? So from 55 and from 25, I'm going to go 15 out again to go 2 standard deviations. So 55 plus 15 is 65, 70. So here's 2 standard deviations. And now he's included. And we have to go this way too. So 25, 35, or whoops, 25. So it's going to be 10. So now we've included all the data. We could say all of this data is within 2 standard deviations. 1, 2, 1, 2 from the median. Or I shouldn't say median, from our x bar. Okay. Does everybody see that? If you plot some data and they ask you how many standard deviations is this data in, you would say it's within 2 standard deviations. Okay, if I didn't have this point or that point, I could say the data falls within 1 standard deviation. Okay, So if you look at problem 7 in your workbook, it says determine the whole number of standard deviations that include all the following data values. So what you're going to do is you need to plug these data items into your list 1 for your data and get your X bar and your sigma. So let's do that. Go to your data list and we're going to enter 2560, enter 57, enter 38.25, enter 126.4, enter 84, enter, and 63.85, enter. Now hit your statistics, calculate, 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 and there they are. So we have 6 items, 1, 2, 3, 4, 5, 6, that's correct. It says my X bar is what? 65.85, correct. And then your sigma is 32.8. Whoops, why do I have 36? That's wrong. Or did I do something wrong? Let me double check the answer key. Oh, it doesn't say. I think it's 3. Did everybody get 32.81? Yeah? Yeah, this is wrong. Okay, so let me ungroup and correct this. Come on, sorry. Oh my gosh. 2.8. Okay? Now, so now we're going to mark our standard. So 65.85 is going to fall about right here. And now we need to plot all these data values on the chart. So 2560 is about here. 57 is about right here. 3825 is about right there. 126.40 is up here. 84 is down here. And 63.85 is about there. So now let's do our standard deviation. So 65.85 minus 3280, and then you want to add 3280 and get your first standard deviation. Is that on here, I wonder? No. So we're going to go 65.85 minus 32.8. So we get 33.05. So it's going to be about right. See, that was a 38. Okay, so it's going to be about right here. So we know it's not one standard deviation, right? Because that doesn't include this value. Now let's add them. And you're going to get 5, 6, 8, 9. So 98.65. Okay, so finish these last 2 problems and turn it in tomorrow, 7 and 8. So they're going to fall within 2 standard deviations. All right, and this concludes our lesson. Thank you. So, make sure you're just working 7 and 8 and you don't do 9, 10, 11. And that's everything.